Where is my thing?
Yeah, you're on your own on this one, man. This is too deep for me. Welcome to the HACKADAY podcast. My name is Mike Stish. I'm editor-in-chief of HACKADAY.
Hey, I'm Elliot Williams. I'm managing editor of HACKADAY.
This is episode 102. Today we're talking about the Raspberry Pi microcontroller, a microphone kill switch, and a 45-degree 3D printer. So, Ellie, we always start off the show with newsy news, and I think everybody will be abuzz this week about the news from Raspberry Pi, but we're actually going to talk about that later.
That is certainly a can't-miss article of the week.
Yeah, so we'll talk in depth about that later in the show. But for now, I wanted to mention that we have published all of the workshops from the Remoticon that was held the end of the first week of November.
Fantastic. Yeah,
I had a great time going through those. I thought everyone did a really good job. I know from, live at the time, something like 24, 25 workshops, something like that. And they all had like a lot of people on them live, which was cool because many of them had interactive parts. But one of the things that was really good about doing this virtual is we had the ability to record these since they were already, being broadcast out of someone's webcam and onto the internet. And so that means everyone gets a chance to sit in on them. And I got to go to way more workshops than I've ever been to, which was kind of like zero in the past.
Yeah, this is an awesome opportunity to just push them out there. I still haven't watched them all. There's too many, actually.
No, I've watched maybe half of them at this point, which I think is pretty admirable.
They're 2 hours long each.
I watched a lot of them on like 2x speed.
Right on.
But I still got a lot of them. I enjoyed them. If you were, at the beer hall with your buddies talking about these, which ones would you tell people to go watch?
I don't know. That's a tough one because some of it is so subjective. It's like I picked ones that were nearest and dearest to my heart and not maybe the ones that would be nearest and dearest to someone else's heart. But let me give you my top three and tell you why.
Go for it.
First up, I think would definitely be the circuit sculpture workshop held by three people simultaneously, Jiri Praus, Mohit Boita, and Kelly Heaton, all of whom are fantastic circuit sculpturalists and all of whom take really different approaches to soldering stuff together and making art out of it. It was really fun because Kelly's much more of an artist, and this is just her medium. And then Jiri, on the other hand, is like totally, this is how you would engineer art. And so they all gave their own talks on it. And so you watch the different spectrums of techniques that they bring to the table. And like Jiri's printing stuff out on graph paper and folding copper wires to exactly match the contours. And Kelly's like, so you take some lumps of clay and you can use these to hold the things together instead of using helping hands. You can just kind of wedge them into lumps of clay as you're going along. Yeah, I just love that one because it was three people whose works I all admire showing their secret tricks, and they were all different.
I think it was difficult to put together a workshop with three hosts, and I think they pulled it off, so good for them.
Next up, Josh Conway's Learning the Basics of Software-Defined Radio, SDR, and that was fun. I am kind of a big SDR nerd anyway, but it was nice to see this as a huge information-dense overview of everything that's been going on in the last 2, 3, 4 years in the SDR scene. And so that's a real good one if you are looking to get into software-defined radio. You should definitely check that one out. And last was Learn How to Hack a Car with Amit Reddy. Amit describes himself as being like an expert beginner. He picked up car hacking as a pandemic hobby, right? He's like, I'm stuck inside. I'm going to at least take my car apart. The workshop aspect of this one's really nice because he's got a demo. These are the signals you get out of the CAN bus and this is what they mean. And it's really nice because it's a really kind of simple step-by-step tutorial. This is where you could trip up. This is what I learned by tripping up here. And then finally, this is how the whole thing fits together.
I really liked Eric Schlepfer's workshop on reverse engineering PCBs. I think part of that is I've tried to do it before, and I was glad to see that I was barking up the right tree a little bit. Like I took a photo of the board and put it into the GIMP image editor and like traced it out in different colored lines and stuff.
Sure.
But he's just so more methodical at it. Like he starts with a bill of materials and you go and like either use the numbers that are printed on the silk screen or assign numbers to each component and then try to fill in like part numbers and values and all that, which is really helpful. And then ends up like taking the picture and like going through and building like a schematic as he goes. It's wonderful. Go watch it. It will be really useful. And then the other one that I just loved is another SDR one. This one is an RF emissions debugging workshop that Alex Whittemore put on and shows that you can use an SDR as like a probe for what you would do in a lab for FCC testing. But instead at your desk, you can kind of trace it down to the part of the board with just a loop of magnet wire. And then you get a probe that has a smaller loop and a smaller loop and a smaller loop. And you can trace it right down to the actual pins that are causing emissions. And it's a really good illustration of how much you can do with really inexpensive and widely available tools. All right, well, enough at the top of the show. Let's jump into those hacks, Elliot.
Okay, my first hack this week is a super clever 3D printing hack. This is printing without support material thanks to an additional axis. This is actually a research project coming out of the Zurich University of Applied Sciences, led by Michael Wörlich. And it is an awesome hack because it's accessible. Basically, the gimmick is he takes a regular 3D printer and adds a fourth axis to the end where the hot end would be, and it kind of can rotate. So instead of the nozzle always pointing straight down, it can kind of rotate 90 degrees to be horizontal. And the trick here is something that's really clever and I think I knew about, but I never thought about it being the solution to this problem. And so that's what I love about it. If you want to print something that like goes out into free space with a 3D printer, it usually doesn't work because it tries to print each layer on top of each other. But the main force there isn't actually the gravity, it's the squishing of the nozzle, squishing that one layer of plastic noodle against the layer underneath it. And so the gimmick here is that they turn the nozzle at 45 degrees. So it's not straight up and down, but kind of 45 degrees over. And that makes the force it's exerting on the next layer also come in at this 45 degree angle. And that lets you get away with essentially printing out into free space.
Yes, you're always pointing at a central axis of your part. And so if you want to build like a cantilevered part out away from it, the plastic is going 45 degrees toward the last part of the current layer that you already printed, which is neat. But even better, if you look at the image at the top of this post, you get this really eerie sense that you're watching a reverse lathe. Like
yeah, right.
The additive being the opposite of subtractive manufacturing is never more apparent here, because on a lathe, if you have something spinning, you would start to see like a cone shape be reduced from the larger spherical shape of the stock. And this is the opposite. You see a cone shape being built out to the final diameter of that piece. Because as the head is given an extra axis, that axis is not necessarily rotating. It's more like it's revolving around the part. And so the part is, I guess, reverse lathing into existence in the middle.
Thank you for saying it that way, because that helps the listeners understand this a lot. The head goes around the part. And so most of the force is the extruded plastic being squished into the piece itself. And like I said at the beginning, this is something we knew before. Man, I can't even remember when the first time I saw a demo of somebody displaying how strong their 3D printer was by holding it upside down and printing. Like, gravity has nothing to do with layer adhesion. It's all about the squish of one plastic into the other. And this is how 3D printers work just exactly the same in space as they work here on Earth. Gravity isn't what makes your prints fall over. It's when you have that print head pointing down, it's pushing the next layer down. And so I thought that was a really great realization. And then the rest is just figuring out the pathing. And
oh, that must be so complicated.
Simple matter of software.
Yeah. Can you imagine?
I can. Like, you totally have to rewrite the slicer. It reminded me also of a 5-axis printer that we saw just the week before that I think we covered on last show even, where you rotate everything to keep it vertically aligned underneath the up and down print head. After having seen it done this other way, that now looks silly and naive to me. So, boom, my mind is changed.
Yeah, I saw this one pop up and I'm like, oh, we published a dupe. And then I was like, ooh, it's something new.
Oh no, it's cooler. And then this, and this also reminds me of my favorite non-regular 3D printer hack, the 3D printing non-planar layer FDM. And that's something I still haven't seen take off, where you print fat layers and thin layers, and so that you can actually print in 3D with the head going up and down as it goes to make actual curvy curves rather than their kind of slice-wise layer approximations. And I still want to see more done on that front, so I'm going to keep bringing it up until somebody does something brilliant.
Big Clive has a really cool video out this week that you want to watch on the Dubai light bulb. Al wrote it up in an article called LEDs from Dubai, the royal lights you can't buy. And it's, I guess, something that you flip the switch and the light comes on and you're very happy. But like all good engineering tricks, when you dig under the surface, it's actually really cool. So this is an LED light bulb that uses those filaments. So if you look at it when they're off, it's like an amber colored toothpick that's inside of the glass.
Right.
And that amber is, it has phosphors in it. And then inside of that is a row of very tiny LEDs, and those LEDs excite the phosphors and they put off the color of light that you're looking for. The interesting thing here is that Philips is making these light bulbs, and of course that's a name known throughout the world, but you can only buy these in the Dubai market because there was an exclusive development project put out for these. And he goes through, I guess we should start with the punchline because you can go and watch the video yourself, and you should, but basically these are being underdriven. And that's something that people talk about a lot, in that, you know, striving for a better price point and striving for, you know, the actual needs of users. Oftentimes we have electronic components that are driven not necessarily for the longest life, but for some other price point that they're going for. And in this case, it just has a really interesting design, which includes multiple filaments where you wouldn't have them before, so that you get the same light output, and then a really interesting driver circuit.
Tell me about the driver circuit.
So in this diagram, you have a capacitive voltage drop that takes the line voltage and gets it down to the point that you need it for the LEDs. But then there's a really clever circuit in there to keep a constant voltage on them. He goes through explaining it, and there's a lot of things that are kind of duplicated, like duplicated capacitors, duplicated diodes. And in the end, he actually puts it on a meter and shows you what it's drawing, and then goes and turns on the electric kettle in his house, and you can see it adjust as the voltage on the mains rails drop because of that new load.
I don't know which is scarier, that his electric kettle drops his house's mains voltage, or that he tried to measure that while it's all alive.
He does mention, he's like, oh, this is a bad idea. He's like probing around while it's still plugged in.
Exactly.
And stuff. But he goes in depth on explaining like how this works and how it's a clever circuit and how it's very different from what you can buy, which would have a lot fewer filaments in them, that they drive those filaments harder. He completely takes apart the little circuit board that's inside of one of these light bulbs. I do like the trick where he takes a picture of both sides of the board and then prints it out in photo quality, but like, you know, 10x the size.
Yeah.
So he can kind of trace around, and he does that for on camera, but I wouldn't mind having that. I just you did that on your computer screen.
That always fools me when I look at his thumbnails, though. I look at the thumbnails of his videos and I'm like, my God, he's got a gigantic circuit this time. Oh, it's just the blown up photos again.
Let's see, what else I like this. He talks about the LEDs and the filaments are flip chips. So instead of having to take a die that is the LED and then bond it to something with bond wires, these have just the balls produced during the manufacturing process, and they can flip it over upside down and then reflow it onto the substrate for the filament.
So basically the gimmick is these get a longer life by being underdriven by having more LEDs in the strip. If you want to read up more on how that whole thing goes, Ted Yapo wrote an article 2 years ago now, what happened to the 100,000 hour LED bulbs. And he finds about the same thing. What happened to them is that A, we're running them hotter, or B, it's actually the electronics to support them that fail out. And the answer to what happened is just not economically viable. So it's neat to see this Dubai light bulb being pushed by regulations about how long light bulbs have to last in Dubai.
There's a lot to be discussed on what things you should be aiming for, but for me, I think the manufacturing process uses a lot of resources. And so
Yeah.
I feel better about things if they just last a lot longer. And so you could argue, well, you have to have, 4 times as many
Twice
filaments.
as many LEDs. Yeah.
Yeah, so you could end up making 4 light bulbs instead of just 1 light bulb. But then, you also have the glass and the base, and you have the shipping, and there's a lot of things and you have to say, like, where are the resources going? Should you replace it 4 times, or should you have one that has 4 times the stuff in it and lasts at least 4 times as long? But I love this design. And the thing is, if you could get your consumers to be fully informed and know exactly what they are purchasing and how it would be used and what it would work out like, then you'd never have any waste.
Right.
We need to engineer better consumers, Elliot.
All right, my next hack is Pen Plotter draws maps directly on the wall, and this one is just so beautiful. You have to go look at the images that we ran as the banner here that are a picture of a wall-size map. I guess it must be 6 meters by 6 meters, or maybe even 8 by 6. It's a big, big wall-size map with superb detail, both of the elevation of the land and the depths of the ocean. And it was all done by a wall plotter. And Christopher Getchman did this all by himself. And that's from the code that slurps the geological data in, to building the plotter, to writing the code that drives it. Originally, he wanted to just put the plotter on the wall and have it draw there, but A, had a little pity on his neighbors who would have to listen to that sound all the time for God knows how long. But also, it was just a lot easier to print these out on the floors. He made a plotter that could draw on 2 meter by 3 meter boards, made each of the map parts separately, and then screwed them up on the wall. This is one of the nicest pen plotters I've seen running in a long time. It's a Core XY build. It runs on that kind of open build linear rail / aluminum extrusion things. It uses the TMC 5160 drivers, which are really nice because they have stall detection and stuff. My favorite hacky moment here was that the software he was using to drive them, Gerbil, doesn't support the SPI-enabled drivers natively. So rather than go in there and hack on the code, what he did was he just bought another microcontroller, in this case an Uno clone, put it on there, had that talk SPI to the different drivers, and then when one of them said, "I'm running too hard," he has that one trip the limit switch on the one that thinks it's driving the motors.
Huh.
And given how cheap those Uno boards are, it's like a brilliant cheap solution to the problem. So I loved that, and I loved his solution to the oceans, where some parts were the deepest parts of the ocean. He'd have to draw over them multiple times. Instead, he just got a bunch of different colored markers, and he did it multiple times, but it made it look even darker. The effect here is just stunning.
Yeah, when I first started reading about this, I assumed it was going to be a string plotter because that's the kind of wall plotters that I've seen. And those have a little bit of difficulty with repeatability. Like if you change out the colors of the stylus that you're using, you might end up with a little bit of, offset between them. But this is, it's got rails on it, so it's pretty repeatable as long as you don't move the workpiece relative to the machine. And so that came out really well. I kind of feel like once you build a machine like this and you get all the software worked out, you have to start selling these things. You have to start selling jobs on them.
Making these maps for everyone you know, right?
Yeah, I wonder if to the eye, these pen plotted maps are really any different than if you just printed them out full color on a printer.
I think so. Like if you look at the close-up pictures he has of it, you can absolutely tell that it was written with a felt tip pen on something, into which the ink bleeds just a little bit.
Right.
And so it really does have a different texture when you get up close. I do just love the way these kind of giant pen plotters can make arbitrarily big pictures, as opposed to your printer, which can't. Because to make something that big, what do you have to do? You have to go to Kinko's, you have to pay them to do it for you, or you have to buy one of their $100,000 printer machines. No, thank you. I'll just screw me together some aluminum extrusion, and I was actually trying to think about it for a second. It's a Core XY, and so it's got to be the perimeter of the frame is 4 meters by plus 6 meters. So it's a 10-meter perimeter on the frame, and I think that's 20 meters of timing belt in that thing. But the result is worth it, folks.
Yeah, what's the stretch over 20 meters of timing belt, do you think?
Yeah, I don't know. He did actually mention that he had kind of loose belts, and I hadn't thought about it. I wonder if it is the stretch. I don't know. You pull on those belts and you tighten them up and they loosen a little bit, and then you tighten them up and then they loosen a bit, and then you tighten them up and they stop loosening after a while.
Don't they also make like a springy part that just rides along on the belt and takes up slack?
Yeah, I suppose you could do that too, right? But then you worry about it springing in regular use, right?
You don't want it to get pulled.
Nah, whatever he did was what I want to do. It was awesome looking.
Elliot, is your Amazon device listening to you right now? Because I'm going to say the name.
Say the name. They're all
I suppose I'm not going to say that.
kitchen.
So you have to say Alexa, right? You don't say Echo.
We've got one of each.
So the Echo is the small version of Amazon's Alexa. Al Williams wrote an article, Is Your Echo Flex Listening? And it is covering Electron Update's really interesting teardown of the mute button on this device. So this has a button you can press and a red light will come on, and that red light is supposed to signify the microphone being off. But of course, in this dystopian age of cameras and microphones always checking us out, people are skeptical I myself included, are skeptical to believe that that button is actually doing what it should. Long story short, it does. It's a really interesting hardware solution. And even more interesting is the teardown that Electron Update did in order to do this. Specifically for me, if you can't look up the part numbers on the circuit board, what do? Well, you decap the integrated circuit and you look at the part number that's etched into the die, and that'll tell you exactly what the device is. And he did that on multiple different parts in order to expose the fact that this, from beginning to the end, has nothing to do with software. There's a hardware debounce circuit that hooks into a dual flip-flop, feeds a NAND gate, and eventually enables a P MOSFET to supply power to the microphone. When it's not supplying power to the microphone, it allows the LED to come on. And so literally there's no software happening here, to the point where even during the teardown, he took the main processor off of the Echo PCB, and this circuit still works.
This is like a classic circuit. It's straight up Don Lancaster, like IC circuit cookbook out of like 1970 something. This is like, it's a beautiful like latching on off switch. And so it's nice to see it being used in this modern era. That's kind of quaint and touching to just see a Schmidt trigger in there. I was really pleased that that was the result. But I'm actually even more pleased that the button does what it says it does on the can.
Yeah.
I love that some of our tinfoilier readers wrote in the comments, oh yeah, but don't forget the speaker can also be reversed and used as a microphone.
Yeah, so if you're getting to the point where there's like a state actor level hack going on, you probably shouldn't have these around anyway.
Yeah, you absolutely shouldn't.
You often just think of like what the company will come out and they'll be like, oh, because of a software bug, we collected a whole bunch of information on 20 million people over the last 3 months.
That's not paranoid. They do that with remarkable frequency.
Yeah.
And whether they say, oh, sorry, we did this by accident after they got caught or before they got caught is entirely relevant. And they always say it after they got caught, which makes you wonder what kind of accident it was.
That's what I'm getting at here is like, this is consumer. This is your average consumer. This isn't your like crazy person. Like, this is how things should be designed so that the average consumer feels like they have some power over their privacy when they want to. And so, if you're going to have a dinner party, you're going to have guests over, and you don't want your Alexa to trigger off during that and make your guests feel like, oh, what I've been saying has been listened to the whole time. You can press the little button and have the red light come on. Now, I was looking in the comments because I was thinking, oh, interesting. The light means not listening.
Right.
And so some of the commenters were like, if you have a conference call with just old telephonics, the mute button turns red when it's on mute. And I thought that was an interesting way to think about it, because that is assuming that the Echo thing is always listening, right? And I guess it is, but I mean, if you think about a teleconference, when you don't have it on mute, that means someone else is at the other end of that. I'm not saying that's what's going on here, but I'm saying it's an interesting place to be in your mind. Another commenter, Doug G, suggested that you should have a blue light for when it's listening and a red light for when it's not listening, which I thought was interesting. But at the same time, if your worry is about privacy, being able to look over and see that the red light is on tells you that it's not listening. And if that red light burns out or something, the failure mode is you assume it is listening. The last thing that's interesting is I don't quite understand the dual flip-flop that's in here, and Electron Update mentioned that it might be for ESD protection, that there's two of them. You really only need one flip-flop. They are reset by a pin on the system on the chip, which to me makes sense because when you have a power outage and you turn it back on, the system needs to have a known state for this hardware circuit. But at the same time, that's an interesting flaw because if someone has it muted and you have an exploit in order to listen to them, except for it's hardware muted, you could, blink the power on the house.
Power down, and then it comes back up on.
Yeah.
Clever.
And then it would automatically be listening. But again, if you think that somebody's listening in on you, you probably shouldn't have one of these hooked up to your network in your house anyway.
I love that people are that paranoid, and, well, no, I don't. It's sad that people are that paranoid, because a good percentage of the time it's justified. But I love that people are that paranoid that they check it out and discover that it's not. And, reporting on a negative result like this is a lot less scandalous and in some ways a lot less sexy a result than, oh my God, they're listening to you all the time. But on the other hand, it's much more valuable to also dig in and say, hey, look, it's not doing anything bad. That's pretty awesome. All right, my last hack this week comes out of the Model RC world. This is Express LRS, open source, low latency, long range RC protocol. If you're not into the long range autonomous vehicle scene, you might not know that a lot of people care about getting super long, 10, 20, 30 kilometers connections with their RC planes these days, but they do. And it's really great when you have an autonomous drone flying around to be able to hear how it's doing and say, hey, come on home, things are going wrong. And that's what these telemetry radios do. They report back to you from your drone out in the field. All the remote control companies have their own kind of proprietary ways of sending data around, and this one is a nice open source protocol. It uses LoRa radios, but then the rest of it is open source. And what I think is really clever about this particular design is that the firmware is written on STM32 chips, which happen to be inside some of the commercial LoRa senders. And so you can reflash existing commercial LoRa senders with a new firmware that actually then increases their performance for no hassle. And if you're a DIY type person, it's just a matter of buying a LoRa transmitter receiver pair and a couple STM32s and soldering it together. And that's fantastic too. And what's even more interesting about this is that a couple manufacturers look like they're going to pick up on this protocol because it's outperforming their protocols so well. That's the ultimate DIY hacker win, right? Here's my super open source protocol, and then the industry is going to jump ship to it.
That is very cool. I love it. For some reason, it makes me think of the Magic Lantern firmware that a lot of people use on their DSLR cameras, right? You had this really interesting piece of hardware, and then you have this awesome open source project that kind of supercharges it all.
And this has a lot of precedent, actually, in the RC world. There's another, this one's a multi-protocol TX module. I'll throw the links in the show notes. This is a marvelous little unit. I actually have one myself. Basically, the idea was to just glue 4 or 5 different radios together to a microcontroller, and that way you can speak to all of these multiple different manufacturers' radios. And this is the multi-protocol module. And what's funny is then a few years later, at least 2 of the transmitter manufacturers have jumped over to this, and that includes Jumper and Rangemaster. And so they've basically copied the multi-protocol module design and put it inside their transmitters, which of course makes their transmitters able to control anything, which is a great selling point for them. And it's this awesome victory for open source hardware, firmware, software. And Yeah, I just love it. If you want to look into this sort of thing, it's surprisingly approachable in the RC world. Hackers, hobbyists can do the really interesting stuff there now and be out on the cutting edge. So much so that, like I said, industry will then pick up your projects and commercialize them for you.
A hacker who goes by the name Mike Buss has a little one on the way and decided that air quality in the house needs to be something that's respected by the 3D printer, and so took on the project of building an enclosure for the top of his Ultimaker that has a fan and a HEPA filter in order to vent all of the off-gassing out and filter it so that you're not breathing it in the room. As happens with many hacker projects, this one kind of took on a life of its own, and I would say benefited from feature creep. In this point, it has a beautiful looking case, and it has the fan and filter like it said, but it also incorporates a flame sensor that will kill the power, as well as an air quality sensor and a couple of different temperature sensors.
Yeah, I really love the look of this edition. It sits on top of this Ultimaker printer. So it's a bunch of Lexan sheets that are held together with little 3D printed corner clamps, and it sits on top of the printer. The aesthetic choice of keeping it all kind of white and clear and transparent looks very almost Apple-y design. He went so far as to spray paint the fan that he's using as the ventilator white. That's one step too far, and I love it.
Well, you can't have a black computer fan on top of this, pristine white printer.
Above a white printer? Oh no.
I think it's interesting that the seams of the enclosure are not sealed. And so you can vent air right into that. It's just at the corners, I guess the 8 corners for the box that have these little printed parts held together by hardware on it. Mike jumps into the comments and some people are asking questions about it, and he says he's working on another version of it. One is that it's difficult to push air across a HEPA filter, and so some kind of design on the fan will be useful. It might just be something as easy as like designing cowls, but it's worth checking out if you're interested in this, because people have put some resources there on existing research into designing around this problem.
I just like to breathe PLA fumes myself.
Yeah. What does PLA smell like, Elliot?
Maple syrup. It's awesome. PLA is the best. ABS smells like you're burning styrofoam in the corner of the room. And that's that one you can tell is bad, but PLA smells delicious.
Well, so another comment on this one is to test it by putting some incense inside of the printer. And I thought that was really interesting because on the one hand, you can see the incense smoke. And on the other hand, if you can't smell it, then your HEPA filter's working.
Oh, that's a twofer. I like that a lot. All right, my quick hacks 3 this week are 2 demystifications and 1 just entirely frivolous hack. Up first is Thea Flowers' the probably most thoroughly commented linker script for the SAM D21 MCU. If you ever code for ARM chips, you always have to include this linker script in there, and usually you get it from the manufacturer and you don't think twice about it. But every once in a while, you need to tweak it to get something done you want to, and that's always been a little bit of a monkey patching sort of affair for me. Thea here does me and probably the rest of the HACKADAY universe a tremendous service by going through each line and providing citations so you can figure out everything that's going on in the linker script for one of these ARM microcontrollers. You should go check it out. Then, Robert Gedulta has written some firmware for his Blade RF SDR, which is an SDR that has an onboard FPGA, and he's written VHDL for this thing to make it do Wi-Fi in the FPGA, and that's saying a lot. He's got a deeper understanding of Wi-Fi than you or I do, and so it's lovely to read his write-up where he goes into how Wi-Fi works and kind of its nitty-gritty. I just think it's a great peek behind the hidden curtain of Wi-Fi, something we use every day but don't really understand. Last up, Joshua Coleman's Apple II prints off the breaking news. Joshua had a really old Epson LQ500 dot matrix printer and an Apple II. So what's he going to do with it? Make a news ticker. Of course, the Apple II isn't connected directly to the internet. He's got another computer in his house somewhere, reading the news, feeding that across a serial line to the Apple II that then prints it out on one of these lovely dot matrix printers. Where the heck do you even get tractor feed paper these days?
First up on my list of quick hacks is an article called Handheld Farkle Really Sparkles by Christina Panos. It seems that Sunny CZ22 wanted to build a travel game of Farkle, something I've never heard of before, but apparently uses 6 dice. And if you don't have a good place to throw those dice, maybe you could just press a button and have electronic dice do it for you. And that's what happened here. The overall aesthetic of the game is really awesome, but what caught my eye is the dice themselves. I thought at first that these had the pips drilled out until you realize that there's 7 holes on them. This is actually 3D printed bezels in the shape of dice with LEDs below them, and it's something to keep in your back pocket if you're ever looking to build something cool. Next up is Arduino Wannabe should have used a 555. Oh wait, it does. Dan Maloney picked up on this. It's a project by Mildly Interested. And Lee decided to take a Arduino Uno form factor, complete with those funky misaligned single pin header pin sockets on either side of it. Grr. And instead of putting an Atmel controller at the heart of it, it has a 555 timer. Could you get anything better in this modern world we live in? And finally, a DIY Lego record cleaner is revolutionary. This is another article by Christina Panos, picked up on Base Rolokus project to clean vinyl LP records. These are like large compact discs, except for instead of having an optical track on them, they had an actual physical track and a needle would read it, for those people that don't remember. And they got dirty, and if you got any lint or dust into the grooves, it would mess with the sound, and so you might want to clean those. This uses Lego on the edges of an ultrasonic cleaning bath, and it rotates the grooves of the record down into the solution to be cleaned, and I guess gently brings the sound back from the good old days. It's time for our Can't Miss Articles of the Week. This is long-form content written by our absolutely excellent HACKADAY writers, and I'm so happy that we're going to talk about one of your articles first, Elliot.
Raspberry Pi enters microcontroller game with the $4 Pico board. This is a brand new project. We've actually had this on the bench for a few weeks now. Raspberry Pi is making its own microcontrollers.
And I hear that, and it's exciting, but then I have to say why.
Because, I don't know. I think it actually fits really well. Like, their whole idea of making the Raspberry Pi was to make a Linux computer, of course,
right,
that was affordable, but then that also had this GPIO header on it so that you could do things in the real world. And after kind of 10 years of experience with that, I think we all have mixed results with the Raspberry Pi GPIO header. Like, it's sensitive, you can blow them up, but mostly there's weird latency and jitter issues because it's connected to this whole Linux not quite real-time operating system on the other side of things. And so if you're doing anything that's like time critical or needs to put out good PWM signals, right, or whatever else, everyone always ends up tethering a microcontroller to their Raspberry Pi project, and that's what they're doing here.
So what do you think about it? It seems to be a pretty mean machine with a lot to offer.
Yeah, I think it's pretty cool, actually. I mean, on one side, it's kind of just a normal microcontroller, except it's got one particular peripheral, and this is the programmable I/O hardware that's just really cool and different. Other than that, it's kind of just a really pleasant, capable microcontroller, but for really cheap. So that's already a win. And then the PIO is pretty rad.
Yeah, so it's interesting that it is custom silicon, but it seems like they're all in on selling it as a module and not as individual chips. Did you get any information about that?
Oh yeah, they'll totally sell the individual chips too.
Really? Okay.
Absolutely. Yeah, no, they got these made at TSMC, they said, and they're just selling the chips. they're
Oh,
interested
that's
in
great.
moving into the microcontroller business.
Yeah, because I liked your analysis on like the power system that they have here. I thought that was interesting. I think one of the things that you said is like comparing it to ESP32. If you don't need wireless and you do need a lot of I/O, I mean, this thing's got a ton of I/O on it.
Yeah, I think that's where this really shines, is that it's got 30 I/O pins and just a really nicely designed interior architecture. Like again, I said they're all basically the same. It's a 2 ARM Cortex M0 Plus cores. So it's actually a dual core chip. It's got a lot of memory, 264K. Like the ESP32 and the ESP8266, it stores its code on an off-board flash chip. So how much flash the microcontroller has is kind of, well, it's a stupid question. It has zero flash. It's all stored off-board, so it's all in the module, which makes it more flexible. On the other hand, the $4 module has 2 megabytes of code space. So I guess the ESP32s that I buy have 4 megabytes. So that's kind of twice as much, but if I'm only ever using like half a megabyte, it's really pointless one way or the other. They have a lot more robust GPIOs. There's just a lot more pinouts than the ESP32. And then this PIO thing is really crazy. There are 2 of these PIO devices, and each one has 4 state machines in it. So you can think of them, each of the little 4 as doing some little subpart of an overall bigger job. And they're kind of this weird cross between being like programmable logic, like a CPLD, and being like a microcontroller. They're actually implemented as being state machines. And you actually would really love to dig into this, Mike. You should go get the RP2040 chip datasheet and go read about the assembly language here, because it's really super clever little assembly language written for these state machines. It's only got 9 instructions, so you can learn it in an afternoon. And they're weird instructions. So the state machines basically are there to manage I/O, right? So it's like set pins, clear pins. And if you think about what you often do when you're at the lowest bit banging level, it's like set a pin, wait, do something else, wait, set a pin, wait. And getting this timings right is pretty critical. They have incorporated the wait a nop steps into the assembly language. So you can say,
Oh,
set this pin and then wait 4 cycles
huh.
as one instruction. And then they did something even crazier. They have this idea of side set pins, which are pins that are just kind of going along for the ride. Think of them like in SPI, it would be your clock pin. And you can also set or clear that in the same instruction that you're loading data to other things. So this one assembly instruction can do basically everything you need to bit bang a pin. It's like set the data on this, wait some, and then toggle the clock pin. And so it's a really concise language for these little things, and it lets it run cycle correct at, full chip speed, and makes your life as the programmer of the higher level code a lot easier, because you just push a byte to this thing, it spits the byte out however you tell it to.
Yeah, that's pretty cool. It reminds me of the PRUs on the BeagleBone chips.
Yeah, exactly. I think that's basically the same idea. They're a hell of a lot easier to use than the BeagleBone PRUs.
Oh, well, those BeagleBone PRUs are like, I think they're dual core processors, like within the chip on the BeagleBone. So yeah, I always thought that they were, obviously a lot of potential, but also a big can of worms.
I banged my head against them for a little while and actually gave up. Shame face. The
Yeah.
PIOs here are actually really easy, and writing this assembler can be done in line if you're using MicroPython. It's actually really cute. They have a little decorator that goes at the top of the function, and you can write the assembly language for this thing as if it were a Python function, and you just throw the decorator at the top, and it knows that it then needs to be compiled and fed off to the PIOs. Whereas in C, I guess you have to put it in an include file. No big deal one way or the other. It looks like, I don't know, I kind of want to just spend some time playing around with them a little bit.
Yeah, same here.
Because you can imagine doing kind of any arbitrary low-level translation on your I/O here. And so it lets you do really fast bus writes without bogging down the CPU. So like if you want to do, I was trying to think of some dumb examples. Their really good one is WS2812 drivers, which use a funny custom, I don't know what that protocol is like. What is that? What is the
one
WS2812?
wired nervous jitter protocol.
Nervous jitter protocol, right? Yeah, it's like long short protocol. And so with just a few lines of PIO assembly, you can write something that mimics this. So, you say, if it's a 1, set it high and wait this long and then set it low. And if it's a 0, set it high for a short period of time and then set it low for a long period of time. That's actually really easy to do in the PIOs. And then all your CPU has to do is spit the data straight out to it, and it takes care of clocking it out to the WS2812s. You could do more complicated stuff like checksums or Manchester encoding decoding or gray coding, or I don't know, one of their examples does DPI video where one of them makes scan line codes and the other packs things with run length encoding. I don't know. There's all sorts of tricks you can do with these. And I think, yeah, we're just at the beginning of seeing what's going to go on with that.
Yeah, I was just thinking of, I have a hack that I did on an piece of exercise equipment where it's sniffing out the SPI signals that are going to the screen on it. And there's this oddball, like non-standard length preamble at the beginning. And I'm using like a hardware buffer to capture, and it's getting off, and I'm losing like 5 bits at the end of it because of this weird preamble. So I think, you could probably write something for this that took into account that oddball protocol and ended up getting all the data that you wanted.
That is exactly the sort of thing that this seems to be designed for. At the end of the day, I don't know how many people will be hacking on PIO assembly themselves and how many people will be saying like, oh, well, that's the module I need and just copying it from someone else, right? But
that's powerful too,
but that's super powerful.
Yeah, you end up having custom stuff, especially because it's $4. Like if someone writes the PRU software to do something cool on the BeagleBone, you still have to have a BeagleBone, which is like $100, right?
But here this thing's $4 and... Oh, like a really good example would be those Hub 75 LED displays. I don't know.
Oh, yeah. I know
if you've looked into them, but they have refreshes that go row-wise, but then they do the top and the bottom simultaneously and staggered and offset in funny ways. This sort of logic would be a piece of cake to put into one of the PIOs. And then your main code could just write normal order to them, and the PIO would take care of the scrambling and the mixing. Anyway, in the end of the day, it's just another microcontroller. It's just another microcontroller with a pretty comfortable feature set. Looks like good attention to detail. The PIOs look like they're a lot of fun, and it comes on a board for $4. So, like you said, I said, if you don't need the wireless of the ESP32, this might be a good choice for you, especially if you want the extra GPIO goodness.
I really enjoyed reading Lewin Day's article this week. It's called TV Detector Vans Once Prowled the Streets of England. And this is something, there are a couple of things here that I had no idea about. One of them is just kind of the reason that these vans existed. Ellie, did you realize that the BBC charges a license to people who are watching the program over broadcast?
Oh, you naive Americans. We do that here in Germany, too.
Yeah, I thought that's interesting. And a lot of people were also interested in that and were like, well, that's so dumb and this and that. But
how do you think your public TV pays for itself? Money doesn't grow on trees, and it's unfair to charge people who aren't watching.
Right. Well, in the United States, there is funding for public television. In the past, there has been a lot more. So, I mean, it's just a different way of collecting that. But the interesting thing is, if you're supposed to pony up your, I think it's monthly, it might be annual subscription fee for broadcast, how do you make sure that people are actually doing that? And so the story here is about vans that were outfitted with multiple antenna, and they would drive through the neighborhoods. I should say it was possible for them to drive through the neighborhoods,
right,
and detect televisions that were on, apparently, by the horizontal blanking signal that was on them. And it's a little bonkers, but I believe it to be totally possible. Like, it's plausible that this could have worked. I would like to point to the article written back in September about the secondhand television in the UK that that was knocking out a whole village's internet every morning when it got turned on because it was
Right.
spewing out a bunch of interference. You know, obviously that's an isolated incident, but it points out that, you know, back in the day, there was, you know, a bunch of extra RF emissions in the tube televisions. And so this thing would be able to be driving down and, you know, they'd be watching, I don't know, waterfall or an oscilloscope screen probably. They'd see a blip and they'd be like, well, that's a television. And then because it was multiple dishes on the top of this thing, they could kind of tell if it was to the left or to the right. And then they could drive forward or backward until they got the highest part of that peak. Now, whether or not this was widely used is what I really question.
It seems like a crazy expensive way to enforce something, right?
Yeah, but I mean, you really only need it's like a spy plane, right? It's like a stealth bomber. You only need one stealth bomber in order to be a deterrent because you just say, well, you can't see this thing. But here's one, and it does all this cool stuff, and we've got a lot more, but you can't see them, right? So if you have one van and you parade it out, you're like, when we have reports that people are stealing the TV or people aren't paying their licensing fee, we're going to drive this van out to your neighborhood and find you. Then a lot of people are in the back of their mind are going to be like, oh, okay, well, I guess I should actually pay attention to this because I don't want to be pointed out as someone that's not doing their part.
Right.
I actually went out and read an article that was skeptical about it. I think it was in Ars Technica from a few years ago, where the person was saying, like, where are the people who designed this equipment? Where are the people that were riding around in these vans? Like, there should be armies of these people. And I think that's a pretty good argument that, you know, having one for the entire whatever, for the entire region is probably all you really needed. For that one person that you knew was watching TV and denied it, and then they can, you know, drive down the street and be like, see, our van showed that you were doing it. And then those stories get out. But I do think it's a little weird microcosm of the cat and mouse of technology throughout history, right? That this not only was a thing that was put in place, but apparently they had a few different iterations of it as the broadcast technology changed.
I like Tempest stuff, and I played around with it myself a bit, and I had one monitor that was just super loud. It gave off the 75 kilohertz signal that I guess must have been like the line rate or something that was just horrible. You could hear it across the room on a cheaply built radio.
Oh, geez.
But then these old TVs, if you think about it, with the giant CRT and 30,000 volts and all of this, they must be spitting out a lot. So yeah, I totally believe it's possible. I guess it's done now, right, with LCDs.
Yeah, and that's kind of where the article went on to, is that it used to be the only thing that hooked up to your TV was an antenna. And so it made a lot of sense that you would pay a licensing fee for this. But then once you start moving to like cable television, and then to streaming television, and then you have video cassette tape players, DVD players and Blu-ray players, you have gaming consoles, and now you have streaming consoles. Like, I would say the minority of television time is spent on antenna, but I still use one. That's all the time we have for this episode of the HACKADAY podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please tell us about it. tips@hackaday.com. And until next time,
keep on hacking.
You're bringing me down with that story. It just makes me think of like Naugahyde furniture.
Blah, blah, blah. What the heck? What happened here? Who took my...
Oh man, I'm gonna have to look this up now. Why didn't I write down better notes? Give me a sec here.
Oop. All right, my last... Breast, what is he? How do you even say that?
Telemetry.
Diddle-diddle-doo. Oh, who's up? Oh, me. Ah.
Quick, hack. Woohoo, we did it.